Hi guys, welcome back to another one of our awesome videos. Today we are doing trigonometry, and sticking to the same question paper. We are doing May June 2022, and hopefully you'll benefit a lot. Now guys, just a quick admin: if you haven't subscribed, please do click on the subscription button and also the notification bell, so that whenever I post a video you are informed. So let's just continue with the business of the day. Question 5. We are given that in the diagram below we have P, which is -7 and 4, and it's a point on the Cartesian plane. We have another point on the Cartesian plane, which is R, and it's on the positive x-axis, such that the angle POR is an obtuse angle. So now what we have to do here, 5.1.1, we have to calculate without the use of a calculator, and we have to find the length of OP. So now if we look at our setting here, let me choose the red color. If we look at our setting here, we have P. The point P is made from the vertical component of the point moving up and down, and then the horizontal component of the point moving left to right. So now if we look at the horizontal component, which is -7, so it means that we have moved 7 units to the left. So the length from here up until here is going to be -7, and then from up and down is our y value, which is 4. So now OP is, if we look at our vertical movement, we form a right angled triangle. So OP is the hypotenuse of the right angled triangle. So now we have to calculate the length of OP. So now if we look 5.1.1, OP squared is equal to -7 squared plus 4 squared from Pythagoras, because we have a right angled triangles. So meaning that OP P, and then if you press into your calculator, you'll get that this is 65, and then OP, not OB, P, just OP is square root of 65. Very simple. So we move on to the next question. We are asked to find tan theta. So this is 5.1.2, tan theta. So we know that tan is the ratio y over x. And what is our x value here? We have, what is our y value? We have 4, and then our x value is -7. So very simple. That's your 1 mark there. And then the next thing we are asked is to find, this is A. The next thing we are asked to find, which is B. So for B, we are asked to find cos theta minus 180. And usually what we are exposed to is the fact that we have a reduction table, and this reduction table is 0 and 360 here, we have 90 here, we have 180. So in naming the quadrant, this is going to be theta, or 90 minus theta. This is going to be 90 plus theta, and then this is going to be also be 180 minus theta, and this is 180 plus theta. This is negative theta, or it's 360 minus theta. So this looks familiar, but now 180 is negative. So what we have to do is factorize a negative here. So what we'll have is cos, and then within the bracket we have factorized a value here, -1. But now if I factorize -1, I have to divide everything by negative. So if I divide theta by negative is going to be negative theta. But if I divide 180 by negative, is going to be positive. So I'll put it here. I'll put it 180 with positive and then minus theta, and it's inside the bracket. Now once I've done this, guys, the 180 minus theta acts as an angle. So let's just say this 180 minus theta, we call it beta. So if now we look at our ratio here, we can say that this is cos negative beta, right? And this cos negative beta is on the fourth quadrant, and cos is positive, so meaning it's going to be cos 180 minus theta. Can you see? Because it's going to be cos beta, then now beta is what? Is 180 minus theta. So now 180 minus is on which quadrant? Quadrant 2, and cos is negative, so it's going to be negative cos theta. And then cos theta is the ratio what? Cos theta is the ratio x. Let me just move there. Cos theta is the ratio x over r. So that is negative, and then our x value is negative 7, and then r is root 65. So now we have the ratio cos theta minus 180 is going to be 7 over root 65. So very simple there, nothing that can shake us. So that is it basically. Let's move on to the next question. Okay, the next question, we have to determine the general solution of sine x times cos x. Let me just write it here. This is 5.2. Sine x cos x plus sine x is equal to 3 cos squared x plus 3 cos x. Okay, general solution, guys. Basically, we have to factorize first. Even in grade 11, this started off in grade 11, where you were exposed to simple general solutions, and we know we are using quadrants, and we can find the general solutions of values. But now here we can't just find the general solution of sine and cos. The first thing that we must do is to factorize, because now we are seeing that there's a sine x in over here, which is sine x cos x, and a sine x. So the common factor is sine x, and if I factorize it here, I'll be left with cos x plus 1 is equal to, and over here I have a 3 and a 3, and then both of the terms have a cos x, so 3 cos x, and then this is going to be what? Cos x plus 1. So now some of you would be tempted to just divide by cos x plus 1 both sides, and then you'll be left with sine x is equal to 3 cos x. Guys, you are going to lose one of the solutions. Remember, when you are having something like this, x squared is equal to x, you don't divide both sides by x, and then now x squared divided by x is going to be x, and then x divided by x is 1. We don't do that. What we would do is to x squared minus x is equal to 0, and then factorize x here, minus 1 is equal to 0, and then we have two values now. X is equal to 0, or x is equal to positive 1, so that it will be positive 1. That's how we do it. Same thing here. would do what would we do here is that this will be sine x cos x plus 1 minus 3 cos x multiplied by cos x plus 1 is equal to 0. Then we would factorize the bracket, which is what? Cos x plus 1. So cos x plus 1 is our common factor, and we'll be left with sine x minus 3 cos x is equal to 0. Then we use the product law. Cos x plus 1 is equal to 0. Then now cos x is negative 1. Can you see? Or sine x minus 3 cos x is equal to 0. Then now we know that this will be equal to 3 cos x. So very simple. We don't just divide both sides by the common factor. We have to factorize so that we can get two values. So now the cos, and then we can find the general solution for cos x and the general solution for sine x. But this one can simplify as we're going to divide both sides by cos x, and then this will be tan x is equal to 3. So fine. The reference angle of negative 1 now. Reference angle of negative 1 is equal to 0. So now the general solution is going to be 180 plus k times 360, because now cos is negative on quadrant 2 and 3, which is 180 plus 0, 180 minus 0, and which is the same as 180 plus k times 360, right? So nothing changes there. And then for tan now, the reference angle here is going to be that is, if you say tan, shift tan 3, you are going to get a value which is 71.57. So now this tan is positive. Where is tan positive? Tan is positive on quadrant 1. Tan is positive on quadrant 1. So we are going to find the solution for quadrant 1. And then which is x is equal to theta, right? Quadrant 1 is theta, and then which is what? 71.57 plus k times 360. Oh, and the general solution for tan is not k 360, it's k 180. K 180, where k elements of integers. And then another one, tan is positive in quadrant, or tan is positive in quadrant 3. So we need a solution for quadrant 3. But quadrant 3 is 180 plus theta. So now it's going to be 180 plus, and then theta, the reference angle is 71.57 plus k times 180, k elements of integers. Then now we have to add 180 and 71.57, which is 251. So it's 251.57 plus k times 180, where k is an element of integers. So that's how we find the general solution for 5.2. Then we continue to 5.3 now. 5.3, we are given the identity sine 3x over 1 minus cos x is equal to 1 plus cos 3x over sine 3x. So we must prove that the identity. So I'm going to prove that the left hand side is equal to the right hand side. So here is sine 3x over 1 minus cos 3x, and I'm going to multiply it by 1, but the 1 is going to be made from the conjugate of the denominator. So so the denominator is 1 minus cos 3x, and the conjugate of that is going to be 1 plus uh, cos 3x over 1 plus cos 3x, and then what I'll have here is sine 3x multiplied by 1 plus cos 3x over. So now if I multiply these two, I'll be having a difference of 2 squares. So the denominator is going to be 1 minus cos squared 3x. If you want me to simplify that, let's just do it on the side. So I'll have 1 plus cos 3x times 1 minus cos 3x, and then 1 times 1 is 1, and then negative cos 3x times 1 is negative cos 3x, and then this is positive cos 3x, and then over here I'll have a negative cos squared 3x. So from FOIL method, fine, and then these two are going to cancel out, and then the denominator now is what is sine squared 3x, because of the identity 1 minus cos squared 3x is equal to sine squared 3x, and then now I'll have sine 3x times 1 plus cos 3x. So now one of the sine 3x cancels with the other one here, and I'm left with 1 plus cos 3x over sine 3x. So now we are having the left hand side is equal to the right hand side. So another thing that I want us to explore is something that I used to do in high school. I don't know whether uh, this is correct. So what I would usually do is cross multiply, meaning for my knowledge is that I'm simplifying both sides, and that would be sine squared 3x is equal to, and I'll have what, 1 minus cos 3x and 1 plus cos 3x. That's what I would do, and then this would be my new left hand side, and this would be my new right hand side. So, and what I would do, I would simplify the right hand side now, and then I would use FOIL method, which now is 1 minus cos squared 3x, which is equal to sine squared 3x. So I want you, I don't know, to ask your teachers, and please comment on the video to say, would this method receive full marks, and would it receive no marks, or would some of the marks be omitted? Just a discussion for that, because for me I find that some of the identities need to be simplified before proven. So what I did here, I cross multiplied, and I had a new left hand side and a right hand side. So please, if you can't answer me, can you also consult with your teachers and leave a comment on the comment section. So this is 5.3.1. 5. Okay, so the next question, we have to determine the values of x in the interval x is element of 0 is to 360, for which the identity is undefined. Okay, fine. So we have to discuss for a moment here what is what does it mean for an expression to be undefined. If you divide 1 by 0, the answer will be undefined, right? If you divide 2 by 0, if you divide 3, 4, 5, 10, 1,000 by 0, your answer will be undefined. So now any value divided by 0 is undefined. So now what does it mean for our expression here? Our expression is sine 3x over 1 minus cos 3x is equal to 1 plus cos 3x over sine 3x. So for our identity to be undefined, it means that our two denominators here must be equal to 0. So now it means that 1 minus cos x is equal to 0, or sine, and this is cos 3x, sine 3x is equal to 0. Then now we can rearrange this, and it's going to be cos 3x is equal to 1. So for which values of x in the interval where x is between 0 and 60, meaning it's x is in the first quadrant. So now we can find a general solution here for which x is between 0 and 60. Okay, so cos is positive on the first quadrant and the third quadrant. Fine. In the first quadrant, we have that 3x is equal to and then the reference angle here, cos 1, the reference angle is equal to 0. So it's 0 plus k times 360, where k is an integer. Fine. So now if we divide by 3 both sides, x is equal to k times 120. And if we substitute k as 0, if k is 0, this is going to be what? 0 times 120, which now x is 0. So we found the first value because it's between 0 and 60. And then if we substitute 1, k, if k is 1, now this will be 1 times 120, and x would be 120. So it doesn't meet our interval here. And even if we use the fourth quadrant, which is minus theta, so it's minus k times 360, it will give us the same value. So what we can take here is x is equal to 0. Fine. We go here. Reference angle here is still 0. 3x is equal to k times 360, where k is an integer, right? That is the first quadrant where sine where sign is positive, right? The second one is where 3x is equal to 180 minus 0 plus k times 360, where k is an element of integers. Fine. So over here, x is equal to k times 120. K is elements of integers. So still, if you substitute 0, it will be x is equal to 0. If you substitute 1, it's x is 120, so we don't want a value greater than 60. And even if we use negative integers, then x is going to be less than 0. So over here I have x is equal to 180, and then what I can do is divide everything by 3. X is equal to 180 divided by 3 is 60 plus k times 3. 360 divided by 3 is 120, so it's k times 120, where k is elements of integers. Now if I put an integer which is 0, then now x is going to be equal to 60. If I put an integer which is 1, then k is going to be 180, which is above 60. So now I have two values now. I have x is equal to 60 or x is equal to 0. So two answers here. X is equal to 0 and x is equal to 60. So that is my answers. I hope you enjoyed this lesson. I do look forward to making more videos like this. Please comment, like and subscribe to keep the channel alive, and I'll see you in the next video.